In the wide range of GlobeCore products, there is one which we would like to point out: the system for production of biodiesel from various vegetable oils and animal fats. Our highest achievement is that we can produce fatty acid methyl esters even from chicken tallow with FFA content 23% or from waste sunflower frying oil. This means that instead of losing this oil or fat, one can use them again to make great environmentally friendly fuel. First, let us take a minute to recall what biodiesel is. Biodiesel is a methyl ester, a product of transesterification reaction. It can be used in diesel internal combustion engines blended with mineral diesel fuel. Biodiesel has practically no impact on diesel engine running parameters, and yet this is nothing compared to environmental considerations. Biofuel combustion does not generate toxic emissions. Carbon dioxide emissions are reduced. The amount of soot is reduced by 50%. 90% of the fuel spilled on the ground is consumed by microorganisms in 3 weeks. Biodiesel is a good lubricant compared to regular mineral diesel. Now that we are familiar with all the advantages of biodiesel, let us speak of our USB units. Continuous biodiesel production is not the cyclic batch production. It does not involve double methanol concentrations, there is no water wash and no recovery of excess methanol. It is an entirely new process developed by GlobeCore engineers, commercialized and marketed under Biodiesel MAC trademark, with the production capacity of the system from 1,000 liters per hour to 16,000 and even more. In the production of biodiesel, our company uses the principle of hydrodynamic ultrasonic high-frequency controlled cavitation. This hydrodynamic technology offers significant advantages compared to competing systems, both in terms of product quality and production rate. Traditional biodiesel production methods require heating the oil to 70 degrees centigrade. This requires significant energy input. There are also the recuperation of excess methanol, additional transesterification, and vacuum drying, which all add to the power bill. The hydrodynamic cavitation does not require any of the above, reducing the power costs by tens of times. There is no need to install expensive portioning pumps. The ejector pulls in the required amount of components. The system is designed for specialized biodiesel production facilities, as well as for oil refineries, food processing facilities, or farms. The operation principle, as exemplified by a demonstrator unit, is to prepare the components and create the conditions required for transesterification. One of the vessels is filled with vegetable oil. In our case, this is waste frying oil. The other vessel is filled with a solution of catalyst in methanol. Then oil temperature is set to 50 degrees centigrade and oil heating is engaged. When the temperature reaches the set point, we start the oil and methanol pumps to circulate. Oil and methanol pass through the mixer and then, mixed, flow into the product vessel, where the liquid fractionates. When water and glycerin separate from biodiesel, we open the corresponding valve on the unit for product output.